Okay, so we will look at the questions for the transformations together, yeah? Okay, let's look at the question here, the first question here. So this is the graph of a fx, okay, that is being transformed to the graph of like 1 plus a f of a half x. So describe fully two single transformation which have been combined to give the resulting transformation. So from fx, okay, it is now being like transformed to become like an f half x, and then we have got a plus a 1 here. So for this one, right, okay, we just need to see what is actually happening there. In this case, okay, the transformation that is being involved here, we can see one is in x direction, which is the horizontal transformations. So another one is actually involved in the vertical direction. So for the transformation that is like, if involves like a horizontal and a vertical. So if horizontal and vertical. So in this case, because the order of doing it will not actually affect. Okay, so when we actually give the transformation, it's up to us which one that we actually want to give first. Okay, if it is one horizontal, one vertical, the order is not going to affect the result. So we can give any one of it first. Okay, so for this, okay, let's say if we just look at the horizontal transformation first. So for the horizontal transformation here, what happens is, okay, we have got the x becomes like a half x. Okay, so for this case, it is actually a stretch. Okay, we need to mention about like the stretch. Okay, in x direction, or you can say parallel to x-axis of, okay, so now the x becomes a half x. So remember for the horizontal transformations, right? The idea is like the opposite of what we like usually think of. So from x to half x, it is in fact like the stretch here is actually involving the scale factor of a 2. Okay, so in the x direction, the thing is like the opposite. So this is for the horizontal. So the vertical, so another one here is because we have got like now we have got f of the x becomes like a f of the half x already. Okay, so now the f of the half x, right, we want to actually plus 1 to it. Okay, so for this another transformation here, it is actually a translation. Okay, we are just moving the graph up by 1 unit. But remember, when we actually want to give the descriptions, right, we cannot use the word which is like up, down, left, or right. You must precisely specify that whether is it like in the x positive x direction, negative x direction, or positive y, negative y direction. Okay, you can actually say that this is a translation of 1 unit in the positive y direction. You can either use this sentence, or the easier one for us to actually look at it is we just use the vector, the translation vector. So we didn't move in the x direction, but in this case, in the y direction, we actually move 1 unit from there. Okay, so this is what we can actually like give for this transformation here. Okay, so yeah, that gives us the 4 marks. Okay, so usually how they award the marks is that, okay, like for the type of the transformation is 1, the specific detail about it is another 1 mark. Okay, so that's why you like by doing this, you can already get the 4 marks from there. Okay, right. So we will look at other questions from there. Okay, so this is the graph, okay, of the fx, which the fx here is a 3 over 2 cos 2x plus a half. So we need to state the range of the f. Here it is about stating the range. So as long as they see the correct answer, then they will actually give the marks already. Okay, but let me just show you a little bit of the working from there. So it is actually something related to our trigo. So it's like cos of 2x is supposingly it is in between -1 and 1 because it is a cost function. If you have got 3/2 of that, we just have to multiply by 3/2 for both the left and the right hand side here, okay, the upper limit and the lower limit. If you have got a +½ so we just have to +½ to all the values there. So this is to show the detailed working. Why do we actually have got something like this? Okay, so you need to state the range of the f. So the final line is what they want to look at for the answer. So upper limit correct is 1 mark, lower limit correct is another mark. Okay. So if you look at the following part here, right? So a function g is such that the gx is fx plus k. The x-axis is a tangent to the curve. So state the value of k and hence describe the transformation that maps a curve fx onto the gx. So we want to actually have like the x-axis is a tangent. X-axis is a tangent means it is touching the curve just by 1 point. Okay. So from here we already know the curve is actually having this range here. So in order for us to actually have the x-axis to touch the curve, we need to move the graph up by 1 unit. Okay, so in that case, it already says that okay, the gx that we want here is the fx plus a k. So this k here is we need to move up by 1 unit. Okay, so state the value of k. So the k here is a 1. So describe fully the transformation. So we have to move the graph up by 1 unit, but we cannot use the word like I said, up, down, left, right like that. So it's either you could use the translation. Translation is to actually move the graph. So x direction, you did nothing. For the y direction, you are moving 1 unit up for the graph. Okay. Other than that, you can actually say that the translation of 1 unit in positive y direction. Okay, so of course, if you already understand how the translation works, definitely the first one is actually the easiest for us to actually state. So we don't need to worry about like writing so many words here. Okay, that's how we actually look at the questions like this. Right. Another one. So state the equation of the curve, which is the reflection of y is equal to fx in the x-axis. Give your answer in the form of like y is equal to a cos 2x plus b, where the a and b are actually constant. So this one is very simple. If you want to reflect the fx in the x-axis, means that we are taking the negative of the fx here. So the y here is actually the negative of the fx, okay? Because we want to reflect it over the x-axis. Just want to just check what is the function that we have for the fx then. So just write down. Okay, so that's the answer, just a 1 mark question. They just want to look at the correct answer at the end. Okay. Okay, so let's look at the next question. So you can see this is also something similar to what we have actually done before. They need us to now state the ranges of the f and the g. Okay, so very quickly, if you actually look at the range of the f here, is to start off with, okay, if the sine 2x is in between 1 and -1, and then we have got like -3 sine 2x is in between 3 and -3, okay, and then we have got like 2 minus, right, so it is actually like a plus a 2. So we plus 2 to both sides there. So this is it, okay? So the fx should be in between 5 and negative. Oh, okay. Wait, let me just... yeah, so this is the range. So, okay, why just now I was a bit doubt is because of the range of the domain of the x given here. So we need to be familiar with like what is the sine 2x graph here. So sine 2x graph is like in 1, 2 pi, we have got 2 cycles. So from 0 to pi, it is actually taking the value of the 1 and the -1. Okay, be careful of the domain that they actually give here. So that's for the fx. So whereas, okay, for the gx there, it is actually -2 multiplied by the fx. So it just have to like, we just need to use like the -2 to multiply by the -1 and the 5. So it gives us like -10 and then also to a 2 for the gx here. Okay, so because like I said, the question is state, they don't really care about the working that we have done. They just want to look at the final answer. Okay, that's for part A. So now they actually gave us the y is equals to fx graph from 0 to pi. So the part B here is sketched on this diagram. The graph of the y is equals to gx. So you just have to be careful in this case here, yeah. Okay, so you see the fx, right, is having the value which is going from like -1 to a 5. Okay, so you see here, this is -1, this is a 5, right? So, okay, so what happened in this case is that we are actually going to like sketch the gx. Okay, so you see, if so, what is actually the gx here? We look at it first. What is the gx here? So the gx is a -2 of the fx. Okay, and then we also know that the gx has this range here. So just to be safe, okay, we sketch the negative gx first. Because negative gx is very easy to sketch. We just need to reflect it over the x-axis. Okay, just for like some reflection. Okay, this is how it looks like. Okay, so you see, this is the negative fx. So when we have got a -2fx, it means that we are taking the double of all the y values that we have here. Okay, we are taking the double of all the y values that we have here. And also look at the range. It is now becoming a -10 to a 2. So if it is a -10 to a 2, it means that, okay, you see this highest point here shouldn't go so high, okay, because this one is only a 5 there. So it could only be a bit like higher there. Maybe this one also draw a bit too high already, okay, maybe like this. So the 2 only can be like here or here, we don't know, right? But, okay, but you see what is actually this value here? So in between like -1 to 5, there is actually like a 2. This value is a 2. So it means when we actually sketch the -2 fx graph, right, it is actually having the highest point, which is here. Okay, so that is a dangerous thing that we could actually, the mistake that we could actually make from there. Okay, because the values then must be matching. So as we actually like sketch this, okay, so we know that there is actually 1 point there. Let me just use the red, yeah. So we know that there is actually a 1 point here. And other than that, like I said, all the y values must be double from the negative fx. Okay, -1 will actually become -2. Okay, and for this minimum point here, it will actually become even more minimum. It has to appear like 2 times, okay, of the original value. And the x-intercept will not change because we only did something to the y. We didn't do anything to the x step. So the x-intercept will not change. So the graph that we're actually looking at for the -2 fx should look something like this. Okay, so this is the important point. You cannot go lower or up higher than the 2 there. Okay, and this point also, this is also important. This is our gx. Okay, so not just simply sketch anything there. When when we actually have like the original graph given, it is not that easy. Okay, when we actually consider like doing this kind of the thing here. Okay, so everything has to be careful and in detail, right? Okay, let's then okay, there's another part there. So the function h is such that, okay, we have got the g, which is like x plus a pi. So describe fully a sequence of the transformation that maps the curve, which is from fx onto the hx. Okay, so from the fx, we need to go to the hx. So it is like, okay, fx, we need to go to gx, and gx, we need to go to hx. Okay, so from fx to the gx, it is actually like, okay, gx is a negative 2 of fx. So that would be, okay, so you see there's a 3 marks, huh? Okay, so here we are looking at from gx to the, sorry, fx to the gx. So in order for us to go from fx to the gx, there are two steps, okay, that could interchange. So you can do like reflection about the x-axis first. So this is giving us the gx to become negative gx, okay? And then now from the negative fx, you want to get negative 2 fx, okay? So this is a stretch in y direction of scale factor of the 2, okay? And in fact, this one is actually interchangeable. You can actually stretch first, then only you reflect. Okay, this one is interchangeable. Okay, and next thing is, okay, we have got the gx now already. So the gx, we want to go to the hx. So the hx here, okay, what happened in the hx here? Hx here is gx plus pi. So now what happens is like the x becomes x plus pi. So it is a translation in the x direction. Okay, but for this translation, because it is something in it is in the x direction, right? It should be the opposite. Although the x becomes like x plus pi already, but we should always think of that as like an opposite. So it is actually a translation, which is a negative pi in the x direction. And why? We did nothing to that. Okay, so this is how they actually give the 3 marks here, 1 mark for each of the transformation here. Okay, so like I said, the first two here is can interchange the order, yeah. But when you actually write the answer, you just need to make sure that your order is correct there. You don't simply write the things here and there. Follow the order. Okay. All right. So not sometimes the question which is involving this is not that straightforward. Yeah. Just have to be careful. Okay. Let's look at the next question. This one as well. They gave us some function. Okay, with the given graph like that here. So the solid line, okay, we can see there's actually a solid line, okay? Solid line is representing fx, and the broken line is the transformed fx. So part A state in terms of f, the equation of the graph shown in the broken lines. So we can see this is actually a reflection in the y-axis. So for the reflection in the y-axis, the x becomes negative x. So for this function here, it is actually a f of a negative x. Okay, that's for part A, 1 mark only. Part B. So from the solid line, it actually became the dotted line. Okay, here we can actually see that the shape here slightly changed. It is actually being stretched longer, and the direction of the stretch is like they stretch it like this. Okay, so how do we actually detect like, okay, it is a stretch? I mean, we know that it's a stretch. Okay, it's a stretch. So what is the scale factor of the stretch there? It is to look at the important points like, okay, this was 1. Now it becomes 2. This was 2. Now it becomes 4. Okay, so all the y coordinates are being doubled. Okay, so if the y coordinates are being doubled, then it is a stretch in the y direction. Okay, so what is the scale factor? We need to it's in terms of the fx, right? Okay, I just write you the description first. So this is the description, but they want us to actually give in the f, okay, in terms of the f. So because the fx is being like double, so this is actually like a 2fx for this graph here. Okay, they just need to see the 2fx and they can give the marks already. Right. So for the part C here, okay, it's a bit of the thing that we need to do. Basically, it is to go from the solid line to the dotted line. Okay, shape is unchanged. So if shape is unchanged, means there is actually no stretching that is involved, and the position change means there is a translation. So we'll just have to see how many like steps that we have actually like translate. Okay, which is okay. We just grab this important point. Okay, let's just take this point. In the x direction, it has actually moved like 4 units to the left. In the y direction, it actually moved 3 units down. Okay, so the translation that is actually involved here is, okay, this is a translation. Okay, that is in the x direction, it moved for -4. In the y direction, it had actually moved for -3. So for this f, right, is f of, if the translation here is a -4, it means that when we change the functions, right, the x here will actually becomes x plus 4. It should be the other way around for the x directions, for all the transformation in the x direction. It should be the other way around. So the fx will become f of x plus 4. And okay, once we do the horizontal changes already, we look at the vertical changes. So for the vertical, it actually moved for -3. So in this case is, okay, for whatever the functions that we have, we just have to -3 from there. Okay, so we just have to minus a 3 from this function here. Okay, so this is the equation of the graph that we actually have for this question here. Okay. So if you look at the following question, okay. So there is a lower curve. Lower curve is a usual cos theta curve. And the upper curve is actually when we applied the transformation, which we actually have the curve line, which is at the upper side there. So find in terms of the cosine function, the equation of the upper curve. So it is to actually use a little bit of the idea for the transformation from there. Observe a few things. One is the cycle actually change. Okay, so from 2 pi 1 cycle, now it becomes 2 pi half cycle. Okay, or in another word, it means that this graph is being stretched with a factor of the 2. That is the first thing that we can actually observe. Okay, so the first step is, okay, once we actually stretch the graph with the factor 2 in the x direction, the first step is that the theta becomes a half theta in the first step. Okay, so the graph for now, it will actually become something like this already. This is the first step. The second step is, okay, if you look at the upper curve again, what is the amplitude for the upper graph? The amplitude for the upper graph there is becoming 2. Okay, so here it means that now we have got okay, we have got the graph which looks like this already. And wait, sorry, let me just draw it nicer. Yeah, I didn't draw it very nicely just now. Okay, so the second step is we actually stretch it. Okay, But the stretch that we actually have here is actually in the y direction. Okay, so this one is when we actually have got the f. Now we have got the half theta already. Okay, becomes 2f of the half theta. So the last step that we actually perform here is to move the graph. Okay, so we move the graph up by 3 units. Okay, so when we move the graph up by 3 units, so it becomes a 2f of a half theta becomes 2f of half theta plus a 3. Okay, that is the transformation that is actually involved here. So when we want to write that as a cosine function, so the y that we actually have here becomes like y is equals to 2 cos half theta plus a 3. Okay, so so if we actually want to check whether our answer is correct or not, you could always sub in some value of the theta here to check whether it gives you the corresponding point on the curve or not. You can always sub values to check. Okay, so the point here is that okay, when we want to do the transformation, right, the order is important. You see, this one it has got a lot of the different types of the transformation that is actually involved, right? The last thing that we want to do here is the translation. Okay, the last thing that we want to do here is a translation, because if we consider doing the translation first, right? Let's say, if we consider doing the translation first, right? Let's say we translate to here, okay, from the very beginning. Okay, let's say we do this from the very beginning. When we actually do the stretching, it will give us a bit of the problem. So when we do the stretching, it will actually become like very weird. Maybe it will become something like this. Not sure, maybe. And later when you actually want to consider like the stretching, it's very difficult for us to actually like match until we actually get this. So usually when we have got the translation, it will usually be the last thing that we want to consider. So it will be easier, we do all the stretching first. Okay, so this is why here I actually chose to look at the stretching. Okay, in fact, the first two steps here can be do interchangeably. You can do the vertical stretch first, then only you do the horizontal stretch, or you can try to do the other way around. It will give us the same thing, because one is horizontal, one is vertical. It's not affected. Okay, so that is how we actually like get this equation here for the upper curve. Like I said, you can always sub in the points to check, because they give us the graph here nicely already. Yeah, so sometimes it's not so straightforward for the questions like this here. Okay. So for the okay, so you see, this is a 3 marks question, and in fact, they actually gave us a lot of the space, right? You need to show a bit of the working. For the working of the transformation, okay, sometimes it is not so formal, or it is not having a fixed way for us to actually do that. So anything that is actually logical, you can just write it down. Okay, because the question is something like find. Okay, it is not state. If state, then I believe they see the 2 half theta and the 3, they will give us a mark already if they say state. But usually if it is a find, right, you need to actually show some working from that. No matter like you draw some sketches on the graph here or you actually write something like this that I actually have done here, you use your own way to actually like find that. Then finally they will actually look at the answer whether it's correct or not. Okay, at least like if your answer is, let's say, not correct, they can check your working and see whether they can give you some marks or not. Okay, this is fine. Right? Okay, so okay, let's look at this. So fx is a solid line, and then the broken line there is the thing that we have actually transformed. Okay, so describe fully 2 single transformation of fxx has been combined to give the resulting transformation. So it's a 4 mark question there. It depends on our strategy here. Okay, how we actually want to sort of like do that here. Okay, for this, we can sort of see that, okay, there are two different transformations here. It could be confused with the translation. Okay, so you see how we could actually do it. It's either, okay, I'll show you two things. It's either you stretch in the y direction first. Okay, so when you stretch in the y direction, what do we see here? The height is actually becoming 3 already. The earlier height is actually a 1. So it means that when we stretch it, the factor is a 3 in the y direction. Okay, so originally it was in 1, 2. If we stretch in the y direction, right, means like if we do this step, it's like our fx becomes 3 times the fx. So this is a stretch in the y direction. So the 1, 2 will become like 3, 6. So this is what we get for the first step here. Okay, and then later on, you just need to do the translation. You just need to move this graph to that. Okay, so how many steps that we have actually moved? We can actually take 1 point to compare. So here it actually gone for 4 units to the right. So the translation, okay, here is a 40. Okay, so this is one of the possible steps, okay, that is actually being performed. So you could say, okay, the first step is, okay, stretch in y direction of scale factor 2. Then you can use the word like followed by, which is translation of the 40. In fact, because one is in the vertical, one is horizontal, okay, it can be actually interchanged as well. So we check that out. It can be interchanged as well. Okay. So if we actually do the translation first, the graph will actually move to here. Okay. When we do the translation for like 40. Okay. Then after that you do the stretch. So when you do the stretch, it is the same thing that you actually get like what I have in the blue curve there. Okay. So this one can be actually like stated like interchangeably one. So that's for part A. So in the part B, okay, state in terms of y, f, and x, okay, the equation of the graph shown with the broken lines. Okay, so this is to state. So, okay, earlier on we already found out that, okay, the fx, okay, it's like 3fx, okay, and then after that, it is a translation of the 40. So for translation of the 40 here, the effect of this is that the x becomes x minus a 4. So the equation of the curve here is y is equals to 3f x minus 4. Okay, so the changes is like fx becomes 3fx, then the x is replaced by x minus 4, so that we get 3fx minus 4. Okay, or if it is the other case, we interchange the order. We will actually have fx becomes like f of x minus 4. Then we stretch it. Okay, so this is what we actually, what am I writing in a scale factor 2 here? It's a 3, yeah, sorry guys. So yeah, this is what we actually have. Okay. All right, let's look at the next question. Okay, this is the question that is could be very confusing and challenging. Okay, tangent graph is some graph that is not so easy to work with because we know that the vertical stretch could be a little bit complicated because if we actually stretch it vertically, it still looks the same. Okay, so that's the difficult part of it. So, okay, the good thing about this question is that, okay, they sort of like gave us the form already, okay? And they actually just need us to state the value of the ABC. So they just want to look at the final answer, no matter what is the working that we have actually like go through. And it also tells us that, okay, the B that we have here is within 0 to pi. So it is to actually help us in sort of like identifying what is actually the A here. Okay, so one thing that we could actually look at is that, okay, we look at the property of the graph here, yeah. Okay, so we see that here one of the thing that it actually tells us, okay, here is that we know that, okay, this is an intercept. So the intercept is actually at like 1/8 pi like that. Okay, and we see, okay, in this graph here, what is the transformation that is actually being performed? It is being moved in the y direction, and it is also being moved in the x direction. On top of that, we might have some vertical stretch, the vertical stretch as well. So this could be a little bit difficult for us to actually like detect. Okay, so we have to actually just try to like one by one from there. So if you actually look at the idea here, yeah, okay, if what we actually have here is that, okay, let's say we look at this point here. This point is when x is equals to 1/4 pi, okay, then we will actually have got the y is actually equals to a 1. Okay, so we can actually sort of get some idea here already. So the 1 is a tangent x minus 1/4 pi plus a c. Okay, the x is 1/4 pi, sorry, 1/4 pi minus b. Okay, so we could actually use another idea here as well. So when x is equals to 1/8 pi, okay, the y gives us a 0. Okay, so if you actually like do this kind of the substitution, right? Okay, is that actually really helpful for us? So in this case, if actually like trying to solve the A and also like the C here, it is like not so, it is actually like not like really helpful. Okay, so we can't really just rely on the substitution like the points here for us to actually solve these the values of the A, B, and C here. Okay, so we could, okay, what we can actually do here is we could sort of, okay, look at where is the graph symmetrical. Because earlier on from the tangent graph, it should be symmetrical like that, right? Okay, it should be symmetrical like this line, about the line, this line here. So we just have to see, okay, whether like what is the point that gives us that symmetry thingy here. So we can actually look at like maybe okay, maybe the symmetrical can be actually observed from, say, if you take this point, right? So where does it like symmetrical? It is actually symmetrical at here. You can see or not? This part and then this part like that. Okay, so it means that this point, okay, this point is being transformed from the origin. Okay, it is being transformed from the origin. So is it that, okay, we just have to investigate here. If it is being transformed from the origin there, okay, is it that the transformation that is being involved here is, okay, if from the origin, we want to transform to here, right? So what is the things that is actually involved here? It is actually moved like this and like this. So we suspect that the translation that is being done here is 1/4 pi, and then we have got a 1. Okay, if this is the transformation, then the functions, right? Okay, you see, so the functions that we have here, right, is we have got the tangent x. It actually become, if we actually undergo this transformation, it will actually become tangent, and then we have got like a this is what is that? This is x minus 1/4 pi. plus a 1. Okay, so this is what we actually suspected. So another thing, if earlier on, if this is our tangent x, right? Okay, what happened if we actually multiply by a to this function here? If we multiply by a to this function here, it is like this, a tangent x. The shape still looks the same and it still passes through the origin. Okay, it will still passes through the origin. So it means that this origin here, when we actually do the transformation, right, it could actually come from the curve which is called a tangent x. So when we do the a tangent x and when we actually do the transformation, right, it doesn't affect the a here. Okay, when we do this 1 over 4 pi, it affects the x. When we do this 1 here, it will just affect the whole thing. We plus the whole thing with a 1. So this is the possible transformation that we have actually undergone here. Okay. So the next thing that we want to actually look at is that we just want to check whether it is correct, okay, for our this form of the graph here. Okay, so we just take one value of the x to check. So for example, like okay, if we actually use back this value, when the x is equals to 1 over 4 pi, we just check, okay, whether it's correct or not. So we sub in into this function here. So the a tangent x minus, the x is 1 over 4 pi. So 1 over 4 pi minus 1 over 4 pi plus 1. So we get like tangent 0 is a 0, plus 1 is equals to 1. So yes, it is actually on the curve. Okay, it's actually on the curve. So, okay, if we think that maybe it is just some coincidence, okay, we can actually submit another value to actually check. Okay, in this case, let's say if we sub in, like, is there any significant value from there? Okay, let's say if we sub in like half pi there. Okay, so when we sub in the half pi, okay, so we get like a tangent half pi minus 1 over 4 pi plus 1. Okay, so what we actually have in this case is that we actually get a tangent. This is a 1 over 4 pi plus a 1. So this is just a plus 1. Okay, so in on our curve there, what we actually have is the value which is a 3. Okay, so if you actually equate this to a 3, then what we have here is that a should be equals to 2. Okay, so overall, when we actually consider everything from there, the graph, okay, for this here should be y is equals to, this is 2 tangent, and then we have got like a x minus 1 over 4 pi plus a 1. Okay, so this is how we actually get the final result for this curve here. Okay, if we still feel that it is, we still feel that, okay, if it is something not right there, we could always just sub like other values to actually check. So you could also do like when the x is equals to 0, the y is equals to -1. You could also get the values up. Okay, so this is how we actually get the graph here. Okay, so the difficulty of this graph is like, it is not like the cos and sine. We can actually see their amplitudes and things like that. Tangent graph, it's very difficult for us to see the amplitude because it doesn't really have an amplitude. Okay, so you just have to try your best to actually like figure out what is the constant A, especially the constant A is the hardest for us to actually detect. Okay, yeah, so that is how we actually do this question here. So you see, although it's a 3 marks question, but it might actually take us some time to actually figure that out. Okay. After all, they just want to look at the constants A, B, and C. They just want us to state. So as long as we use any our way, or any our method to actually find that, as long as they see the answer is correct, they will just award the mark to us. Okay. Okay, let's just look at the other questions from there. Yeah. Okay. This is a graph of like y is equals to fx is transformed to the graph which is like a y is equals to 2fx minus 1. Describe two single transformations that have been combined to give the resulting transformation. From here we can see that one is horizontal, one is vertical, so the order doesn't matter. So okay, so here we have got like okay, we can see that first is the fx okay becomes a 2fx. So this is a stretch. Y direction, scale factor of the 2. I just write some short forms here, yeah. And then now from 2fx, it becomes like a 2 of a f of x minus 1. So from x, it becomes x minus 1. Okay, so this one is when we actually have got a translation. So it's a translation in the x direction, which is a 1, 0, because x becomes x minus 1. In the x direction, the transformation is like the opposite of usually what we think. So this is a translation of the 1, 0. Okay, can be interchanged, yeah. Part B, okay. Curve sine 2x minus 5x is reflected in the y-axis and then stretched by a scale factor of 1/3 in the x direction. Write down the equation of the transform curve. Reflection in the y-axis means we try to bring the negative of the x. Okay, so it becomes like, okay, sine of negative 2x plus a 5x. Okay, so sine of a negative angle is a negative of the sine. And then it is being stretched, okay, by scale factor 1/3 in the x direction. Okay, so stretch in the x direction, but it is 1/3. So for this case, should be like x becomes a 3x. It's the other way around, okay, in the x direction there. So the equation is like, finally, we get negative sine 2, so the x becomes a 3x here. So we get negative sine 6x plus a 15x. Okay, both are in x direction. So this is the difficulty about this question here. So again, it's a write down. So as long as you get the final answer correct, they will just give the marks. Okay. Okay, this one is a mistake, yeah. I don't know why I actually include that in. Okay. For this one is find the values of like the positive integers a, b, and c. It depends a little bit on our knowledge on the trigo as well as like the transformation. It's very easy. We just need to identify, okay, what is the amplitude? So the amplitude here is, okay, so we have got like from 8 to negative 2, right? So the amplitude here should be a 5, okay? So this is like a middle of that. So if the amplitude here is like a 5, so the A here is automatically a 5 already. Okay, so here is a 3, right? So it means that it's being moved out by 3 units for this graph here. So the C here is a 3. And we just have to look at the cycle to determine like what is a B here. So if this one in 2 pi, there are 2 cycles. So it means here the B must be already like a being doubled. So it's the answer is being doubled. So the B here is actually a 2. Okay. So once we actually have like the values of the A, B, and C already, then we will actually like get the marks lah. All right.